So we'll pick up here with our test or exam 1 review, question 19, and we have a question about velocity. So we got some details about a stone. The thing we're most interested in is the equation of the position of the stone after so many seconds. So S is the height of the stone after so many seconds. It's a position function. When we take its derivative, we get the velocity function. So find the average velocity over this period. So it's the slope of the position function. So the average velocity will be between 1 and 4. We need the positions at those times. So when t is 1 and when t is 4. So again, we plug those into the function, so we get s of 1. And my favorite way of doing this is, let's cancel that, I guess, whatever that is, using the graphing calculator. We'll put this back up here. So we'll just enter it in. Let's clear out this one. We'll enter our 1500 minus 110, and again you put in what you've got, x minus 16, and remember that 16 comes from a constant of gravity, feet per second, something along those lines, x squared. So you kind of see things thrown down. So the downward force is 110 feet per second. It starts at 1500. Those where that come from. And the 16 comes from gravity. So let's go to, table set. I just want to make sure I'm on auto. We need to start at 1 or 0. Let's start at 1. And let's have our table change by 1. So it's going to go 1, 2, 3, 4, 5. Now let's go second. The graph button, which is table, it gives us our table. When x is 1, t is 1, then the y value is 1374. When the t is 4, then the height is only 804 feet. So we just need to get the slope between these two. So we can do y2 minus y1 over x2 minus x1. So I'll do that formula. So and you could choose either one for y2 that you want. I'll go ahead and use the 1374 as our y2 minus 804. And since 1374 is first, 1 has to be first down here. Notice we will get a negative value because in the bottom we get negative 3 in the numerator. We are going to get a positive value, but a positive divided by a negative ends up being negative 804. We go 570. 570, we divide that by 3, or negative 3, we get 190, negative 190. So the average rate of change is 190 feet per second over this time interval. Average velocity, so velocity would be minus 190. We do put the negative, that gives direction. Estimates its instantaneous velocity at time t equals 4. So now instantaneous, that's the nice thing about having the graphing calculator, having the formula, the function in the graphing calculator. We can actually go to the graph. Now just thinking we're going to need our window to see everything, so it starts off at 1500. So yeah, 1500 should be good. That's the top and it's going to be dropping. So we should be fine there. X max, I don't know, maybe 10 seconds will be long enough, and we'll go from 0 to 10 seconds. So there's our window. Certainly 10 seconds was long enough. What we want to do is we want to find the derivative at 4 seconds. So we go second calc. We want to find the derivative, so that's number 6, at 4 seconds. So we enter 4. Now you see the x equals 4. You hit enter, and it gives it to you that our derivative is negative 238. So that's our instantaneous rate of change. So you know, it's speeding up. It first had 110 feet per second. Now it's speeding up. It's negative 238 at that instant. And just as a reminder, if you needed to get the tangent line here, remember you can go second program. That's the draw. Let's try that again. Second program. It's the draw function. We can draw the tangent line, which is number 5. All we have to do is enter the value 4, enter, and you'll see that the slope of the tangent line there is negative 238. And you've got the full equation, and there's the tangent line. Okay. Compute, so that's 19. 20. Compute the derivative of f at a algebraically for the given value of a. So again, how do you want to find this? As long as we don't have to show our work, we can do it anyway. We can graph this, find the derivative at 4. So we just pull up our equation, our calculator. In the y1, we'll put x to the third plus 3x. I will go to zoom. Since we're looking at 4, let's just do a zoom standard. Probably will show enough. So at 4, what we want to do is find the derivative. We go second calc. Number 6 is the derivative. And then we have to enter what x value we're looking for. We're looking for x equals to 4. So we hit 4, enter, and we're given that the slope at x equals 4 is 51. Okay. We'll round it. We don't need that 0.0001. Algebraically, you could also do that. So the derivative function, the 3 comes down, so you get 3x squared, 3 minus 2 plus 3. We're going to plug in x equals 4. So we want the derivative at 4. We get 3 times 4 squared plus 3, so that's 16. 3 times 16 is 48, plus 3 is 51. Okay, either way you want to do it. So this is following the directions, doing it algebraically, and algebraically for the given value of a. Again, same thing, you could do it either way. Plug it in the calculator, which is using, as we found, a balance difference quotient, or you could do this one. We'll do f of x. We'll just rewrite this as negative 9x to the minus 1, so that when we go to take its derivative, we get the negative coming down, so negative 1 times 9 is positive 9. Subtract 1 from the exponent, we're going to get minus 2, and then we're going to plug in a equals 1, so we get the derivative at 1 is equal to 9 times 1 to the negative 2. 1 to the negative 2 is still 1. 1 times 9 is 9. Our answer is 9. Okay, you could have done that with the graphing calculator as well. This one looks somewhat familiar. We've got crude oil production from 2008 to 2013, approximated by this function. T is time in years since the start of 2000, so when T is 8, that would be 2008. That makes sense. Find the derivative function, so the derivative function dp dt, or just p prime. That's all it's really asking for. This is the same thing as p prime of t. Remember, different notation. Newton's notation p prime, Leibniz notation dp dt. Okay, so we're going to take the derivative, so the 2 comes down, 0.017 times 2, so you can double that, that's 0.034 t to the first power, right? 2 minus 1. The middle term, take its derivative, the 1 comes down, so that's minus 0.4 t to the 0 power, which is 1, but we don't have to write it, and the last part is 0. So that is the derivative that goes into there. We're done. Now, at what rate was oil production changing at the start of 2011? T equals 11. Well, we plug in 11 here. And again, our units are millions of barrels. The units here are millions of barrels per year. So 0.034 times 11 minus 0.4. And we come up, it was decreasing. So the answer is negative 0.026. That's the derivative. But since it already says decreasing, we don't want to put in the negative. We just want to put 0.026. Okay. That's 22. 23. Obtain the derivative dy dx. Again, this is can be written as y prime either way. So we're just bringing the exponent down and subtracting 1. So y prime, or dy dx, negative 1 times 5 is negative 5, x to the minus 2, subtracting 1 from the exponent. The 1 comes down, so we've got a minus 4. 1 minus 1 is 0, x to the 0 is 1, so that's negative 4 times 1, so that's all there's there. This is a constant, so when we take its derivative, it's 0, so you could have a plus 0 here, but we don't write that. There it is. Okay. State the rules that you used. Well, what did we use? We certainly used the power rule, because we used exponents, power rule. We did not add anything, so we have not used the sum rule. We did use the difference rule, and we also used a constant multiple rule here, because we multiplied by 5 and 4. Okay. Find the derivative of this function. So the derivative here, we bring the exponent down, so 3 times 9 is 27. Take 3 minus 1 and you've got 2, so 27x squared. This 2 comes down, 2 times negative 4 is negative 8. Subtract 1 from the exponent, 2 minus 1 is 1. And then the last term is x to the first power, so the 1 comes down, so it's plus 1. 1 minus 1 in the exponent gives us x to the 0, which is 1, so this is it. This is our derivative here. Okay, so just put it in the box and you're done. Find the derivative of this function. Okay, so what's the derivative of this function? Again, bring the exponent down and multiply. So 0.5 times 7 is going to be 3.5. 0.5 minus 1 is going to be negative 0.5. Over here, we're going to take the negative 0.5, bring that down, so you're going to get minus 3 times negative 0.5 is negative 1.5. multiplying by multiplying by 0.5 is the same thing as dividing by 2. It's a half. Okay, and then when you subtract 1, you're going to get minus 1 minus 1.5 because they're both negative, so you add them together, so you should have minus 1.5. There's our function there. It's 25. It's a long test. I've been working on it. Hopefully you have too. So find the derivative of this function. What we're going to do is we're going to rewrite this function with negative exponents so that we can take a look. So this is going to become 9x to the minus 1 minus 2x to the minus 3 plus 1x to the minus 4. So that when we take its derivative, the exponents come down, so negative 1 times 9 is negative 9. Subtract 1 from the exponent, we get x to the minus 2. Negative 3 comes down and multiplies, so that gives us a positive 2 times 3 is 6. Subtract 1 from the exponent, negative 3 minus 1 is negative 4. Negative 4 comes down, multiplies times 1, so you get a minus 4x. Minus 1 from the exponent, minus 4 minus 1 is minus 5. So that is our derivative. 27. Find the derivative of this function. Again, we are going to rewrite this. Now, when we move the x up to make it x to the minus 2, we do not move the 3. The 3 stays where it's at. So we're going to rewrite this as r of x equals 2/3. We're going to bring the x up here, make that to the minus 2. This one, the x moves up and multiplies times 1, so that's all that's there. There's an invisible coefficient of 1 here to the minus 2.6. Now we just take its derivative by using the power rules repeatedly. So the 2 comes down, we get negative 4/3, right? Negative 2 times 2 is negative 4. X, subtract 1 from 2, negative 2 minus 1 is going to give us negative 3. And then negative 2.6 is going to come down, so a negative times a positive is negative 2.6, really multiplying times 1, right? X, and then subtract 1 from the exponent, we're going to get minus 3.6. And that's what goes in the box. We're getting close here. Find the derivative of this function. Again, we're going to rewrite it with exponents. So s of x equals x to the 1/2 plus 7 times x to the minus 1/2. Now if you wanted to use 0.5, you could do that, all up to you. The derivative, let's have the 1/2 come down in front, and then it becomes x 1/2 minus 1, which again we write as 2/2, is going to give us minus 1/2. Negative 1/2 times 7, so we are going to rewrite this as positive times a negative. So it's going to be minus 1/2 times 7 is 3.5, or 7/2, however you want to write it. Subtracting 1 from 1/2, so that's minus 2/2, so notice that's going to be minus 3/2. And they don't say anything about formatting, so this would be a correct way to leave it as. Again, you could also have it as 0.5 x to the negative 0.5 minus 3.5 x to the minus 1.5. You could do that too. Either one of those in there is a correct answer. Find the equation of the tangent line to the graph of the given function. So again, we can go ahead and take the derivative, plug in 3, and that gives us a slope. And then you can find the points. What my suggestion is just using the calculator. You can actually find the tangent line all in one step. Okay. So you plug in the equation x plus 3 over x, 3 divided by x. It's our function. We go ahead and graph it. I'm going to do a zoom standard just to be sure. So we get this kind of thing going on. We want to find the derivative or the tangent line at x equals 3. So we go second, draw, right? Draw is a shifted program button. So I'm right here. Get this. I go down to number 5. 5 is what I want to do. I want to draw a tangent line. I hit it. And then now this is where I need to enter the value of x I want to use. X equals 3. I just come down to the 3 button right here. Click on it. It says x equals 3. I now click on enter. And it in one fell swoop draws the tangent line for us. It says it's at x equals 3, and it gives us the equation of the tangent line, 0.66666, which is 2/3. So you could do that, or you could put all the 6's plus 2, or you could recognize that that's 2/3 x plus 2. Okay. The nice thing about this is when you've done it this way, you see the graph, so you can easily identify the correct one. It's no, this isn't it. You know, that's down here at -3. Hopefully you would have seen that anyway. Sure looks like here 1, 2, 3. So I would say it's got to be. I mean, doesn't that look the same? It sure does. I'm going to mark it before I do too much else. But as we come through these other ones, we see this is backwards. That's not correct. And this is also backwards. It's not correct. Okay, so the graphing method is very helpful in this particular question for 2 reasons. It gives us the equation that we need quickly, and it gives us a visual of what we're looking for, which is what they want us, they want us to say this is the right one. Question 30. Find all values of x, if any, where the tangent line to the graph of the given equation is horizontal. Horizontal means it has a slope of 0. Tangent line is horizontal when its slope is 0. They even tell us that. Okay, good. They remind us. Enter your answers as a comma list. So we're going to find out where it's equal to 0. So we first have to take the derivative. But before we take the derivative, we're going to rewrite this all in terms of exponents. So we got 4x minus 4 to the x to the 1/2, 0.5. We'll just do that. Okay. We'll take the derivative. Derivative here, 1 comes down, 1 times 4 is 4. Subtract 1, 1 minus 1 is 0, x to the 0 is 1. So there's the variable's gone. Here we have the 0.5 coming down, multiplying times 4. 4 times 0.5 is 2. It's divided by 1/2. So I've divided by 2. Okay. And then we have x to what? The minus 0.5. And so another way we could write this that maybe looks a little better is 4 minus 2 over the square root of x. We're going to set that equal to 0. Let's just add this term 2 over square root of x to both sides. So the 4 just gets left there. We add 2 over the square root of x here. So it becomes positive on this side. We add it to 0. And then what I like to do, since we've got 2 fractions equal to each other, we can cross multiply. So we get 4 square root of 2 equals 1 times 2 is 2. Divide both sides by 4. Not square root of x. Okay, square root of x right there. Okay. So that cancels. We get that the square root of x equals 1/2. Square both sides, you get that x equals 1/4. Looks like we've done this at some time. And there's only one answer to that. Not 1/2, 1/4. 0.25 if you want. And because a square root function, goes up like that, so there's only going to be one place that'll give us the 1/2. Okay, so we've already done the other problems. This should take care of us. Study well. I'll post some instructions, and hopefully all goes smoothly for you. Thanks for participating.